Kia ora tātou, welcome to this video on acid-base reactions. I've decided to split acid-base reactions into two videos because it's a relatively complicated part of the reactions that we need to learn. So in this video we will focus on acids reacting, or specifically carboxylic acids, because that is the acid that we have learnt for organic compound, the organic compounds topic. So just a bit of a summary, a bit of a revision of last year. Acids are proton donors. We can also, proton and hydrogen ions are the same thing. So some examples of acids that we looked at in year 11 would have been HCl, HNO3, or H2SO4. And so all of these acids have one thing in common, and that's that they all contain hydrogen ions. And so when they partake in a reaction, they will donate that hydrogen ion to another molecule. Now, something that we looked at last year was that if we had a solution of water and we were to add HCl to that solution, then we said that the hydrogen ions, we would say that HCl would dissociate. So the hydrogen ions would break apart from the chloride ions. This year what we're going to learn is something slightly more advanced than that, but it's effectively the same thing, is that instead of hydrogen chloride just dissociating like that, sure, that will happen, but the hydrogen chloride, we show that it can react with water, and when it reacts with water, this hydrogen is actually donated to the water molecule, and so we get H3O plus Cl minus. So this H3O plus is called hydronium ions. So it's the same thing really as what we learned last year. It's just a slight advancement on it. So when we've got a solution of hydrochloric acid, we're going to have the chloride ions in there, and instead of just saying H plus, we've got the H3O minus. H3O plus, what am I saying? And this would be an acidic solution. So something also to remember relevant to the organic topic is that acidic solutions, if we were to put blue litmus paper in an acidic solution, then the blue litmus paper would turn red. So we can use this if we have an identification question where we need to identify an unknown solution, and one of them might be an acid. We could put in some blue litmus paper, and if that blue litmus paper turns red, then we can say that it's a carboxylic acid, or at least an acid. So let's look specifically at what reactions carboxylic acids can take place in. I've got it nicely written down here. So it's similar to what we had before, where if we were to draw an ethanoic acid molecule, OHO, then this can react with water, and again, just like hydrochloric acid, it will lose that hydrogen and give it to water. So this is going to turn into, and we've drawn these double arrows here. You'll learn what this means in the chemical reactivity topic, so I won't go into that. We've got those double arrows there, and we end up with CCOO and then O minus, because it's lost its hydrogen. And just like what we were talking about last time, we've got the H3O plus. So this, because we've formed this H3O plus in a solution that contains ethanoic acid, it is going to be an acidic solution, so it would turn blue litmus paper red. And then this ion that's left over when ethanoic acid loses a hydrogen ion is called ethanoate. So anytime a carboxylic acid loses a hydrogen ion, we change the end of the name from enoic acid to enoate. So ethanoate, butanoate, propanoate, it just means that the carboxylic acid has lost its hydrogen ion. Another reaction that carboxylic acids could undergo would be if we had the same ethanoic acid, then it could just react with a base. So if we could do either sodium hydroxide would be one common base, or Na2 sodium carbonate. So remember that carbonates are bases as well. And whenever we have an acid react with a carbonate, a metal carbonate, we're going to get a salt. So the salt will be sodium ethanoate. So I'm just going to draw this as the condensed structural formula this time. COO minus. This is drawn here just to show the exact same thing as what I drew there. And then we would have a sodium ion bonded to it with an ionic bond. And we're also going to get carbon dioxide plus H2O. So the carbon dioxide we will observe as bubbles. So again, if we had an identification question where we had unknown solutions and we had sodium carbonate that we could add to them, then we would be able to say if the solution was an acid, then we would observe bubbles coming from that solution. So this is if we've reacted this ethanoic acid with sodium carbonate. If we reacted it with sodium hydroxide, we would still get this sodium ethanoate ion here, or sodium ethanoate ionic compound, but we just wouldn't get the carbon dioxide. That's the only difference. And that's everything that we need to know for acidic reactions, so the reactions of carboxylic acids. So I'd best just do some practice with this. I understand it is quite a stretch. It is more difficult than the other organic reactions that we need to know, but you can get there. Believe in yourself. We got this. Keep watching. Tune in for the next video. Thanks everyone.